Hi guys, welcome back to this channel. In this video, we're going to look at the topic data storage and compression. And at the end of this lesson, you should be able to understand how data storage is measured, how to calculate the file size of an image and sound. You should be able to understand the purpose and need for data compression and the two types of data compression. Now, measurement of data storage. So we say that zeros and ones are the building blocks of a digital system. And these ones and zeros, they are called bits. Okay, each is called a bit. And we say that a bit is the basic unit of all computing memory storage. Now, byte is the smallest unit of memory in a computer system. And 1 byte is equal to 8 bits. So instead of saying 8 bits, we can just say 1 byte. Half a byte, which is 4 bits, is called Nibble. Okay, now let's look at the memory size system in a computer. So instead of always saying the memory size of a file in bytes, okay, instead of saying 1024 or 1,048,576, these numbers are difficult to remember. So we can always use this memory size names. Okay, 1 GiB, 1 MiB byte, 2 raised to power 30, 1 GB byte. Instead of saying these values, we can just say 1 TB byte. So these are the memory size of a computer system. Now let's look at how to convert from this memory size to one another. So we are going to be converting this byte to GiB. So to convert this byte to GiB, first let's convert to GiB. We divide by 1024, and then we have this in GiB. If to convert this GiB to MiB, we divide by 1024, and then to also convert further to GiB, we divide by 1024. So if we don't want to divide one by one, we can just say 1024 times 1024 times 1024. Whatsoever answer we get, so we can now divide this value by this answer. So that is how we change from byte to GiB. Now let's convert from GiB back to byte. So we are converting from GiB back to byte. So what we do is we multiply by 1024, and then we get the value of the MiB. Then we multiply by 1024, we get the value of GiB. We multiply by 1024, and then we get the value in bytes. If we don't want to take these 3 steps, we can just say 1024 times 1024 times 1024. Whatsoever answer we get, then we multiply it with 64. So that is how to convert between memory size. Now let's look at calculation of an image size. So to calculate an image, the formula we need to use is image resolution in pixels times the color depth in bits. So for an image, to find the image resolution, it's the number of pixels that makes up an image. So for example, the number of for the length, let's say this is 3, and then for the height is 4. So to find the image resolution in pixels, we need to say 4 times 3. That is the image resolution, and then we multiply with the color depth that is given. Okay, so the formula to calculate the file size of a sound is sample rate times sample resolution times the length of sample in seconds. Okay, you need to take note of this because in exam you might be given the length in minutes, so you need to convert to seconds. And this is for mono sound. If it is a stereo sound, that means that we need to multiply our answer by 2. Now let's take an example. So we need to calculate the file size of an image, and the formula is image resolution times the color depth. So remember we said that image resolution is the total number of pixels, which is the pixels on for the height and then for the length. So we have 1024 times 1080 to find the image resolution, and then we have the color depth in 32 bits. Now the question further says how many photographs of these would fit into a memory stick of 64 GB. First of all, let us find the file size. Okay, so we find the image resolution and then we multiply by 32 to find the file size. So this is the file size and this is in bits. So because this is in bits, we need to divide by 8 to get the size in bytes. Remember we said that byte is the smallest unit of a memory in a computer system. That is why we need to change to bytes first. Now that we have changed to bytes, then we need to know how many of this photograph will fit into a 64 GB. So basically we need to say 64 GB divided by this image size. Now we cannot do the division because 64 is in GB, so we need to make sure they are in the same unit. So to make sure they are in the same unit, we change 64 GB to bytes, and then we divide by the size of the photograph, and then we have 15,534 photos. So this is the amount of photos that can fit into a 64 GB memory. Okay, now let's look at another example. We have a camera detector has an array of 2000 by 2048 by 2048 pixels and uses a color depth of 16. Find the file size of an image taken by this camera in MiB. So basically they want our final answer to be in MiB. It's the same step, image resolution times the color depth. So an image resolution is this value times this value. Then we get this value in pixels. Then we multiply by the color depth. Okay, so we have the answer in bits. Now we need to change to bytes. To change to bytes, we divide by 8. And then we have the value in bytes. Now we are asked to convert to MiB. From bytes, we have keep. And then we have MiB. So basically we have 1024 times 1024. So this value is 1024 times 1024. So we divide by this value and then we get 8 MiB. Now let's look at another example. So calculation of file size of a sound. The formula to calculate is sample rate times sample resolution times length of sample. And we have been given the sample rate, which is 44,100. We have been given the sample resolution, which is 16 bits. And the length of the sample is 60 minutes. So this is in minutes and it has to be changed to seconds. So that is why we have 60 times 60, which will give us the value in seconds. So to calculate 44,100 times 16 times 60 times 60, we have this in bits. And because the question says it's a stereo recording, which means we need to multiply by 2. Okay, so we multiply the answer by 2 and we get bits. Now we need to change to byte. To change to byte, we divide by 8 and then we have this in byte. We cannot leave our answer in byte. We have to for sound we have to always change to MiB. So to change to MiB, remember from byte to keep and then to MiB. So we have 1024 and then 1024. So this multiplied by this, we have this value. So we need to divide by this value to get 605 MiB. Now let's look at data compression. So sound and images files can also be very large. And because they are large, it's necessary for us to reduce the file size. So what are the reasons why we would want to reduce a file size? Okay, number one is to save storage space on your storage media. Okay, either your hard disk drive or your solid state drive. If a file is too large, it can take up almost all your space on your storage media. So we can reduce the file size. We also reduce file size to reduce the time it takes to stream a video or a music file. We reduce file size so as to reduce the time it takes to upload and download files across network. If you have a 1 GB file and you have a 5 GB file, okay, this is going to take shorter time to upload and download compared to a 5 GB file size. Then also the download and upload uses up network bandwidth. The higher your file size, the more network bandwidth this file will use. Then to reduce the file size, also to reduce cost. So when we reduce the file size, we are reducing cost. For example, if you look at your cloud storage, maybe like your Google Drive, your Apple cloud storage. So if you reduce the file size, then you save more storage space instead of paying for extra storage space. For data compression, we have two types. Okay, file can either be compressed using either of these two methods, either a lossless compression or a lossy compression. Now let's look at each one by one. Okay, so we have lossy file compression. Now this is a type of technique that eliminates unnecessary data from file. When these files are compressed, it will remove some data that are unnecessary in the file. And one of the disadvantages of using this technique is that the file cannot be reconstructed once it has been compressed. So when you have reduced a file size and you want to change it back to the original, you cannot get the original data back again. So that is one of the disadvantages of using lossy algorithm to compress. So now, for example, when we use lossy file compression algorithm, so what it does to an image is that it reduces the resolution of an image, or it reduces the color depth of the image. For a sound file, it reduces the sampling rate or the resolution of the file. Okay, so let's look at some of the common lossy file compression algorithms. We have the MP3, MP4, and then we also have the JPEG. So MP3 are used for playing music, and If we apply a lossy algorithm, it reduces the size by 90%. So when it reduces the size by 90%, what happens to the file? It removes the sounds that are outside human hear range. So the sound that we human cannot hear when we are listening to the music, it removes these sounds, and then it eliminates softer sound. So this is how it reduces MP3 file. Then for MP4, which allows storage of multimedia files rather than just sound. So when these movies are streamed, it can be streamed without losing any real discernible quality, meaning that you would not notice that the quality has been reduced. Then we have JPEG. So JPEG is a lossy file algorithm that is used for images, and when these images has been compressed, it cannot be reconstructed back to the original form. So when these files are reduced, there are two things that it takes away. Okay, it removes color shade that human eyes cannot detect, and then it separates pixel colors from brightness. Okay, let's look at lossless file compression. So this technique, when it is used, all the data from the original file can be reconstructed back. Okay, meaning that after the file has been compressed and we want to uncompress it back, we can get the original file that the file was in the first place. So no data is lost. No data is lost. We use this kind of techniques if we want to keep all the details in a file. If all the details in a file are important, then we use lossless file compression. And the algorithm for lossless file compression is called run length encoding. Run length encoding. So it's a type of algorithm that is reversible. It can reverse the file back to the original state. And how does it do this? It reduces the size of a string of adjacent and identical data. Okay, we are going to look at what that means in the next slide. So an RLE is effective where there is long repeated units or bits. Let's look at the example so that we can understand better what that means. Looking at this example, now this text, each letter requires 1 byte. And if we count, we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 16 bytes. And we can see that the text has repeated values that are adjacent. It has repeated values that are adjacent. So because it has repeated values that are adjacent, the data are identical, then what we can do is we can, for example, these 5 letters, we will count how many letters is it. 1, 2, 3, 4, 5. So we write 5, and then we check what is this value in ASCII code. It is 97. So we then store these two data, which is 5 and 97, and this two data is just 2 bytes. It's just 2 bytes. Then same also, we count, we have 4B, and B is 98. So we store these two data, which is 2 bytes. Same for this, and then same for this also. So if we count how many bytes we have here, we have just 8 bytes. So we can see that the original file size has been reduced by half by using run length encoding algorithm. So that is how run length encoding algorithm works. Let's see an example of RLE with images. So looking at this image, we can see we want to save the letter F, and one box represents 1 byte. One box represents 1 byte. So a white has a value of 1 and a black has a value of 0. Each box is 1 byte, so that means we would have 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 8 will be 64 bytes. Now, instead of this 64 bytes, how does RLE reduce it? So first we count the number of the boxes with the same color. The first 8 and then continued, we have 9W. Then the black is 1, 2, 3, 4, 5, 6, 6B. Then the white 1, 2, 2W. The black is 1B. Then the white is 1, 2, 3, 4, 5, 6, 7, 7W. The black is 1B, and then continue like that. And then we will have all of this value. So if you count, okay, let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is 15, that's 2 times 2, that's 30. So we have 30 bytes. So we can actually use RLE to reduce the file size, and then we have 30 bytes. So instead of 64 bytes. So that is how RLE is also applied when reducing the file size of an image. So that's all for this lesson. Thank you guys for watching. If you want to understand this lesson even better, refer to the video topical past year questions.